Welcome to this channel. In this particular tutorial, we will design the CMOS inverter circuit and we will realize how equalizing delays can be used to reduce the skew in the circuit. So before going into this tutorial, I request you to like, share and subscribe to my channel below for more such videos. Now click on new schematic and select the component. Now in the component section we have to place a PMOS and an NMOS transistor. So select the PMOS and place this particular PMOS on the schematic window. Click escape. Now again click on component and select the NMOS and place this particular NMOS on the schematic window. Next we have to define the models for this particular PMOS and NMOS. So right click on NMOS and define the model name as N underscore 50 nano, define the length as 50 nano and define the width as 500 nano. Now right click on PMOS and define the model name as P underscore 50 nano, define the length as 50 nano and width as 1 micro and click OK. Now click on wire and connect the drain of PMOS to the drain of NMOS, and the gate of PMOS is connected to the gate of NMOS. Now click on ground and place the ground on the schematic window and click on wire, connect this source of NMOS to the ground and click on ground and place this particular ground on the substrate of this particular NMOS. Now click on component and select the voltage source. Now place this particular voltage source on the schematic window. Now click on ground and place the ground on the voltage source and click on wire, extend this particular wire and extend this particular wire across the source of PMOS and place the label as VDD across the voltage source V1 and right click on this and define the DC value as 1 volt. Similarly, place the label VDD on the extended wire across the PMOS and across the substrate of PMOS. Next, place the label net input on the schematic window, click escape and we have to place a label net out. Select the port as output and place this on the schematic window and click escape. Click on wire, connect the input and connect the output as shown in this particular tutorial. Now we have to define the model for this particular schematic. So click on spice directive and type dot include bsim4 underscore models dot text and place this on the schematic window. Now this particular schematic must be saved in the folder where we have this bsim4 model. So save this particular circuit in the file where the bsim model is present. Now save this particular schematic. Now click on hierarchy and click on create a new symbol. Now click on draw and select rectangle. Now draw a rectangle as shown in this particular tutorial. Now we have to place the input and the output port. So click on edit. Now click on draw and place a line across the input and across the output. Now again click on draw and draw a line across both ends of the rectangle. Now click on edit and click on add port. Define this label as in and place this input pin. Similarly, click on edit, click on add pin port and define the label as out and place this particular label, pin label justification on top and place this as the output pin. Now click on draw, click on text and define this as inverter and place this inside the rectangle. Now click on file, click on save as and save this particular symbol in the library folder of LTspice. So save this as CMOS underscore buffer as the symbol name. So this particular symbol name must match with the schematic name what we have saved. If there is any variation, then you would end up getting error. Now let us open another schematic window and select the component as CMOS underscore buffer which we previously saved. Now place this particular inverter symbol on the schematic window. So we require a 2 inverter symbol and also we have to place the capacitor C1 and capacitor C2 as shown in this particular tutorial. Now connect the output to the input of second inverter and connect the capacitor as shown in this particular tutorial. Now place a ground connection and click on wire, connect the capacitor to the ground. Right click on capacitor and define the capacitance value as 50 femtofarad. Now click on component and we have to place a voltage source. So place this particular voltage source on the schematic window as shown in this particular tutorial and click escape. Now place the ground connection and connect the input to the voltage source V1. Now click on ground connection and place the ground on the voltage source V1. Now extend the wire and place a label as out, V out, and place this across the output of inverter 1 and place the second label as Vout2 across the output of inverter 2. Now right click on voltage source V1 and select the pulse. Define the initial value as 0, V on as 1, delay T delay as 1 nanosecond, T rise as 1 nanosecond, T fall as 1 nanosecond and T on would be 0.5 nanosecond and click OK. Now go to file and save this. You can save this as CMOS underscore buffer circuit and save this particular circuit. Now go to edit, click on spice directive, and we have to include the bsim model. So dot include bsim underscore bsim models dot text. Save this particular schematic where this bsim4 model is present. Now go to edit, click on spice directive and define this as .tran 2 nano and place this on the schematic window. So now let us run this particular simulation. Now place the probe on the input of inverter 1 and place the probe on the V out 1 and place the probe across the V out 2. Now the time skew added to the input signal can add up and result in the timing error. So what we can do is that we match the load of each inverter and the propagation delay would be more similar. Add a capacitor C2 and place this across the V out 2. Now right click on the capacitor, define the capacitance value as 50 femtofarad and click on ground. Place the ground on the schematic window. Now click on wire and connect the capacitor C2 to V out and connect the capacitor other end of capacitor to the ground. Now run this particular simulation. Now place the probe on the input and place the probe across V out of inverter 1 and place the probe across V out 2. Now we can see that in order to equalize the delay, the second inverter would need an additional bit of loading. The input signal should transition faster in an attempt to match the transition times of the inverter. Thank you for watching this tutorial. I hope this has helped your learning purpose. I request you to like, share and subscribe my channel below.